This is 1976 AP Physics B exam question, and it says a conducting bar of mass m slides without friction down two vertical conducting rails, which are separated by a distance L and are joined at the top through an unknown resistance. The bar maintains electrical contact with the rails at all times. There is a uniform magnetic field B directed into the page as shown above. The bar is observed to fall with a constant terminal velocity v sub 0. On the diagram here, draw and label all forces acting on the bar. Because the bar is moving down at the constant velocity, that means the force acting on the bar down, the force of gravity, so I'm just going to write mg, is compensated with the force acting on it up, which is the magnetic field force. So I'm going to call it FB. For B part, they say determine the magnitude of the induced current I in the bar as it falls with constant speed v sub 0 in terms of, and then you have to write your answer in terms of all these variables. Also, when you write the forces acting on the bar, make sure that the force down, mg, or the force of gravity, is the same force as force up, the gravitational field force. Because if you make one of them longer, that will tell the examiners that you don't understand that the forces are equal to keep the constant speed or no acceleration. So these two forces should have the same length when you draw them. So for B part, we have to set up two forces. So here is B in green. So I have to set up two forces equal to each other, or F net is equal to 0. So I can write F net is equal to ma, and because there's constant acceleration, constant velocity, there's no acceleration. So I can say that F magnetic field minus the force of gravity is equal to 0. In other words, the magnetic field force is equal to the force of gravity. So the magnetic field force is B Li and equals to mg. And so to solve for current, you have mg divided by B times the length. For C part, they ask you to determine the voltage induced in the bar in terms of, again, B, L, G, V, and M. So I'm going to do it in blue. So in order to calculate the EMF, you have the number of the loops, which is one loop, and then you have the change of the flux over the time. So the flux is going to be, let me call maybe this part W, and this part is given the length. So this is L. So I have, for the flux, I have B times the area over the time. So that gives me B times the length times the width over the time. And the width over the time is actually the velocity at which it moves, v sub 0. So I can have BL and v sub 0. So your formula that they ask you, the EMF, is equal to BL and v sub 0. They also did not ask you the direction of the current and which current is going to be flowing, so I still want to go over this. So because your magnetic field lines are going into the page, and that is increasing the amount of the magnetic field inside of this loop. So because the magnetic field is increasing, then the current that is causing the magnetic field has to decrease this increase in magnetic field. So the current will have the magnetic field that is going into the page on the top of the bar and out of the page, so out of the page on the top of the bar and into the page on the bottom of the bar. So that means the current has to be going in this direction. So that would be the current, and it goes that direction, this direction, and then this direction. So that is your current. And to see that it is in this direction, so if I have in this direction the current, then my right hand rule, I have to set my thumb this way, and then I have to curl my fingers like this. And the direction of the magnetic field is going to be coming behind the current and in this direction. So it's getting out of the page on the top and into the page on the bottom. And for the last part, for D, they ask you to determine the resistance in terms of B, L, G, V sub 0, and M. So if I'm looking for the resistance is going to be the voltage over the current, and we found both values. So the current is, the voltage is your EMF, and the current is the one that we found earlier. So the EMF is equal to B L V sub 0, and the current is equal to mg, and then you have to bring B and L to the top, and that gives you squared and squared. So your resistance is going to be equal to B squared L squared V sub 0 over mg. And that is it for this question, and see you in the next AP Physics question. Thank you for watching this.